Okay, so let's get started. So trigonometry, in order to start it, we need to define it. Okay, so trigonometry consists of three primary functions. It's kind of one of the nicest parts of mathematics because it takes several different areas of mathematics and combines it. So you're going to see obviously our trigonometric functions, which we'll get to in a second, but then you're also going to see a lot of geometry in there and a lot of algebra in there, and a lot of logical thinking as well. So you're seeing the crossroads of a lot of different areas of mathematics here. So let's start with the trigonometric functions, and you've probably heard of these before. Okay, we have sine, we have cosine, and we have tangent. So in order to understand what these are, let's first talk about triangles, okay? Because trigonometry is based on the triangle, specifically a right triangle. So if we take any right triangle, okay, keep in mind that in a right triangle, you have a right angle. Okay, this symbol, if you don't remember from geometry, this symbol means our right angle. Right angle is 90 degrees. This side is the hypotenuse, which is the longest side. The hypotenuse only exists in a right triangle. You don't have a hypotenuse in any other type of triangle. Okay, the hypotenuse is always opposite the right angle, and it's the longest side of a right triangle. Okay, let's talk about how we label triangles. It's the same regardless of what type of triangle you're working with. Just so that it's easy for you to refer to, this is universal. So the angles are labeled with uppercase letters. So we could call this A, this B, this C. There's nothing that says that it can't be, that you can't label this angle for example A, this one B, and this one C. Typically in a right triangle, we like to label the right angle C. You'll see why in a second, but it's not written in stone. Okay, so the angles are in uppercase. The sides are in lowercase, and the side that's opposite that angle, it's going to have the same letter but in lowercase. So this angle is A, the side opposite it, which means the side that is not used to create the angle. So every angle is created by two sides. If we took this side away, you would still have an angle A. Okay, so this would be side A. Opposite angle B, we have side B. And again, if we erased this, so let's just do that. Hopefully it'll just erase that side. It didn't. If we take out that one side, you still have an angle B. So that's how we know what's opposite, okay? And that means that this side is side C. And one thing that many of you are going to be familiar with is something called the Pythagorean theorem. Please be careful when you spell this. I expect you to spell it correctly. I have seen some very weird spellings, so make sure that you spell it correctly so everybody knows what you're talking about. And the Pythagorean theorem says a squared plus b squared is equal to c squared. Now you covered this a long time ago and hopefully you proved it back then. So I'm not going to take the time to prove it here. If you do want to prove, then obviously contact me during my office hours, send me an email. You can also look this up. Okay, so a squared plus b squared is equal to c squared, and that tells us the relationship between the three sides. Okay, so we do have a relationship between the three sides of a right triangle. This is just geometry. What you'll see in a few minutes is that trigonometry is the relationship between sides and angles in a right triangle. So we're adding in this angles part, which here we don't have. Okay, it doesn't matter what these two angles are. A squared plus b squared equals c squared will always be true. Okay, let's go in and talk a little bit more about labeling. So first of all, a couple of other things that you need to know. We have x as a variable. Okay, we use x typically as a variable, but that usually is for things like distance. It could just be any unknown, and we can always use x. But for angles, a lot of times you'll see something else used as the variable, as the unknown. And what you'll see is it looks like a 0 with a line through the middle. Okay, this is pronounced theta. It's a Greek letter. And it's a variable used for angles. So if you're writing an algebraic equation like 3x plus 2, you typically aren't going to see a theta. It's not going to be 3 theta plus 2, because that would indicate that you're working with angles, and we're not. Whereas when we're using trigonometry, we are working with angles. So you're going to see theta a lot more instead of, let's say, x. Okay? And it's not that you'll never see x, you will, but you'll see theta frequently. So I want you to be familiar with that. And theta is just x. Okay? It's an unknown. Okay. So when we label, we can label a right triangle. And the way that we label it, so this is how we label the sides and the angles as unknowns. Okay? But each of these we can label in a different way. And the way that it's labeled is based on whatever angle we're using at the moment. Okay? So if we are choosing to use this angle here, okay, so we're looking at it from the perspective of that angle, then we could label the sides as the side opposite the angle, the side adjacent the angle, and the hypotenuse. Okay, so each of the three sides can be labeled differently. So the three sides can be labeled as opposite, adjacent, and hypotenuse. And the hypotenuse we already know is always opposite the right angle. Okay, that symbol is used to represent angle. The opposite is the one that is not used to create the angle or to form the angle. and the adjacent is needed to form the angle. There are always two sides that form the angle. One of them is the hypotenuse, one of them is the adjacent. So the adjacent would never be the hypotenuse. Okay. Opposite will typically use the letter O, adjacent will use A, and hypotenuse will use H. Okay, so let's label this triangle based on this angle here. So notice that if you change the location of the angle, if we use the angle at the top instead, then the location of the opposite and the adjacent is going to change. Okay, why do we say that? Well, first of all, the hypotenuse we always know is opposite the right angle. So if we were to draw some sort of line that goes from this corner of the triangle across, this would be the hypotenuse. Okay, and again, what we're saying is we're saying if we were to take out this line, we still have the right angle, and that's how we know that this is the hypotenuse. We don't need this line in order to create the angle. And that's how we figure out the opposite for theta as well. We say, which line can we erase so that we still have the angle there? So if we erase this line, then part of the angle disappears. Same thing is true if we erase this line. So the only line that we can erase so that the angle is still there, okay, so that theta is still there, is this one here. So this is the opposite. Once you know two of them, you know the third. But the adjacent here, we have two sides that make the angle, right? So in this particular triangle, the hypotenuse is one side that makes the angle, and the adjacent would be the other side that makes the angle. So that would be the adjacent. Okay, and we're just going to do this with a bunch of different triangles that are in different configurations, okay? And I want you to notice that if we used theta up here, then the side opposite would be this one, okay? So the opposite and the adjacent switch when we change the location of theta. So I'm going to write that in there just so that you have it. But you should be able to see it as we label these triangles. And theta is never going to be the right angle. So this would never be theta. Theta is here or it's up at the top, okay? Okay, so let's take a bunch of different triangles and just label them opposite, adjacent, and hypotenuse. After like the second one, you should start pausing the tape, doing it yourself, and seeing if you get it correct. So I'm going to just draw a bunch of triangles and then we're going to label them. And that way when you pause the tape, you can pause it and then do a lot of them at once. All of them are going to be right triangles, so you're going to see a right angle in all of them. You can't do this with a different type of triangle. Okay, so let's take these 7 triangles and just label the opposite, the adjacent, and the hypotenuse, okay, based on the angle that you were given. So here we're given the angle over here. So you could start with whichever one you want. If we start with the hypotenuse, if we take this right angle here and we just draw a line across, this tells us this is the hypotenuse. Again, if we were to delete this side here, we would still have our right angle, okay? The opposite is going to be the one where if we take away the side, we're still going to have theta, okay? You can also, again, just draw a line across. This is your opposite. And then what's left over is your adjacent. Your adjacent is the one that's next to the angle. Adjacent means next to, okay? If 2 people are sitting adjacent to one another, they're sitting next to each other. So if this is the hypotenuse, that's one of the sides that's next to theta. So the other one must be the adjacent. Okay, let's take this one. We're just labeling the sides opposite, adjacent, and hypotenuse. Whenever you're ready, you should pause the tape, try and do these yourself. Okay, so again, let's do the opposite first this time. So the opposite is going to be across theta. So this one is the opposite. The adjacent is the other side. So it's the other one that creates the right angle. So this is the adjacent. And then again, the hypotenuse is left over. Once you can do 2 of them, you can always do the third because it's just whichever side is left over. Okay. In this one, if we do the adjacent first, the adjacent is the one that you'll see connected to both the right angle and the angle, okay, because the adjacent is needed for both of them. So that's this side here. You see the little square is attached, and the theta is next to that side. So this is adjacent. This one is the hypotenuse. This one is what's across the right angle. And then the one that's left over is the hypotenuse. Sorry, is the opposite. Okay. Here, the hypotenuse across from the right angle. The opposite is across the theta. And then the adjacent connects both. It's used for both angles. Okay, in this one, the hypotenuse is across your right angle. Your adjacent is the one that's connected to both theta and your right angle. And your opposite is what's left over. Here, the side opposite, we could draw a line through the theta to this bottom side here. That's opposite. The hypotenuse is our longest side. It's opposite the right angle. And then the adjacent is the one that uses both angles. Okay, that helps form both angles. Here, we have this side here. This side uses both theta and our right angle. So that side is the adjacent. This side is our hypotenuse. And the side that's left over next to our right angle is the opposite. Okay, so this is how you label your right triangles. Okay, so from here, we're ready to define our trigonometric functions. Okay, and these are definitions. They're not calculations. We are simply defining. And the definition of a trigonometric function is the ratio of the sides of a right triangle. So that's what trigonometric functions are. Okay, they are definitions. Okay, meaning you need to remember it. Okay, there's no way around it. You just have to remember. So we have 3 of them. We have sine of theta. Sine of theta is typically abbreviated just as SIN. It is pronounced sine, not sin. Do not say sin. It is a sin to say sin. You say sine. SIN is an abbreviation only in writing. Okay? So the sine of theta. Now, you have to have a theta here. This is like log. You can't take the log of nothing. You have to take the log of something. So something has to follow. You have an argument that follows the log. Following the sine, you have an angle. Okay? The reason why you need the angle is that the sine is based on the definition of sine is based on the sides of a right triangle. And as you saw, in order to label the sides of a right triangle, we needed to know where the angle is. If we don't have an angle, how are we supposed to know which is the opposite, which is the adjacent, and which is the hypotenuse? Over here, how would you label which is opposite, adjacent, and hypotenuse? You wouldn't know. The hypotenuse you know, because it's always opposite the right angle, but the opposite and the adjacent, you would have no idea. So you would need to be taking the sine of an angle. And the sine of the angle is the opposite side over the hypotenuse. So typically you'll see it abbreviated as sine is O over H. Okay, by definition. Then you have cosine. So cosine is abbreviated COS. Again, you pronounce that cosine. It is just abbreviated in writing. This one is the adjacent over the hypotenuse. So this is just rewriting it. It is A over H. Okay, so typically adjacent is just A, hypotenuse is just H, opposite is just O. Then we have the last one is tangent. It's abbreviated tan. A lot of times you will hear people say tan of theta. You will not hear people say, and you should not hear people say cos of theta, okay? So this is the only one that sometimes people will speak the abbreviation to. And this one is opposite over adjacent. So tangent of theta is O over A. And again, I'm going to emphasize, if you leave out the theta, then you are incorrect. You are not writing a statement that makes any sense. If you have a function, you have to know it's a function of x. Here you have a trigonometric function. You have to know what your input is. Your input is theta. If you just write tan equals O over A, you are incorrect. Okay, now some people have a way to remember this. They use something called SOHCAHTOA. I'm a little hesitant to show this to you because if you don't spell this correctly, then you get it wrong. Okay, so SOHCAHTOA, each group of 3 letters gives us a different trig function. So this one gives us sine of theta. This one gives us cosine of theta. And this one gives us tangent of theta. Sine of theta, so the first letter gives us which the trig function it is. Then the 2 letters that follow give you the definition. So sine is O over H, cosine is A over H, and tangent is O over A. If you spell this incorrectly, then you're going to get it wrong. So you should only use this if you know how to spell it. But honestly, it's 3 definitions. You can remember the 3 definitions, okay? So sine is O over H, cosine is A over H, and tangent is O over A, okay? And we can make some conclusions about sine, cosine, and tangent. So first of all, H is the longest side of a triangle, which means O is always going to be less than H. Now we know something. When the numerator is less than the denominator, our number is going to be less than 1, okay? So if I have 2 over 3, that's a number that's less than 1. If I have 5 over 6, it's a number that's less than 1, okay? So sine of theta is always going to be between 0 and 1. Now, for right now, we say between 0 and 1 because we're dealing with right triangles and each side of a triangle has a positive length, okay? So let's just put that in here. For a right triangle, sine is going to be between 0 and 1, and so is cosine. Okay. Tangent could be infinite. Okay. Tangent could be a very, very large number, or it could be a very, very small number. Okay. That's because there's no relationship between O and A. O could be very, very small, and A could be very, very large. You could have a triangle. So this could go up to infinity because we could have a very large number or a very small number. So this would be an example of a triangle. Let's say that this is theta. This is your right angle. Here, your O is very small, and your A is very large. So your A is greater than your O here. And you could have the same thing the other way. Your O could be very, very large. So if this is theta again, here your A is very small and your O is very large. There's no relationship between O and A. Okay. This is theta. Okay, so O is much bigger than A here, but here A is much bigger than O. Okay, and what you'll see here is over here in a triangle like this, our sine is going to be bigger. Okay, it's going to be closer to 1 because O is bigger. Okay, so if you have 2 over 3, 5 over 6, 7 over 8, these are numbers that are close to 1. So your sine is going to be closer to 1 here, whereas your cosine is going to be closer to 0. Okay, and tangent is closer to infinity. Now, it doesn't mean that it's really, really large, right? If I have, let's say that our theta, let's say that our opposite side is 200 and our adjacent side is 2. You get a large number, but it's not infinite. It's just that it's a larger number, okay? It's increasing. It's a larger number. Whereas when A is greater than O, the opposite happens. The sine of theta is closer to I should say to 1 then 0. This is to 0 then 1. And this is really what we're saying here is we're saying that it's larger than 1. We don't know how much larger. It could be much larger. It depends on how much larger the opposite side is than the adjacent side. So here, sine of theta is going to be closer to 0 than 1. The cosine of theta now is going to be closer to 1 than 0. And the tangent of theta is closer to 0, meaning it's less than 1. Okay, it's just giving you some idea as to what's going to happen to sine, cosine, and tangent so that you can look at your answer and you could say, oh, hey, it's reasonable. Okay, so how can we use sine, cosine, and tangent? Well, if we're talking about right triangle trigonometry, because eventually we'll talk about other types of trigonometry, okay? If we're talking about right triangle trigonometry, then we're using it to find missing sides and angles. Now, this is true for triangles that are not right triangles, where I'm not going to spend a lot of time on that. But eventually we're going to be working with circles in the next lecture. So that's why I say in right triangle trigonometry. Call them trigonometric functions. Okay, so let's take an example. So we're going to do it mathematically first, and then we'll talk about some examples in the world around you. Okay, let's start with missing sides. So what do we mean by this? Suppose that we have a right triangle, and here's your right angle, and I tell you that this is 61 degrees. Okay, so that angle is 61 degrees. And I tell you that the hypotenuse is 10 centimeters. This is obviously not drawn to scale. And you want to find this side. And we'll call that side x. So notice we can use x. We would not use theta here because theta is not an angle. Okay, theta would not be an angle. This is a missing side, and theta is only used for angles. Okay. So in order to do this, you're going to ask yourself two questions. You're going to say, what do we know? And you're going to say, what do we want to find out? And when we're talking about missing sides, we're saying, which side do we know? This is your first question. Your second question is, which side are we trying to find? So your first step here is to label your triangle because you can't figure out which side we know and which side we're trying to find until we label the triangle, okay? And when we say label the triangle, we mean with your opposite, your adjacent, and your hypotenuse. Okay, so let's do that. So you're given an angle. Here's an angle. That's the angle that we're going to use in order to label our triangle. So the side opposite that angle is this empty side here. This is opposite. This side X is your adjacent. And this 10 centimeters is your hypotenuse. So now we can answer these questions. Which side do we know? Well, here we're given the length of 10 centimeters, so we know the hypotenuse. And then we're saying, okay, well, which side are we trying to find? Well, that's this side, that's the unknown side, and that's the adjacent. So the third question that follows, and I put this in red because this is like the big question in solving, okay, is which function uses the two sides we found in 1 and 2? And which function is that? Well, it's cosine. We have hypotenuse and adjacent. Cosine uses hypotenuse and adjacent. The cosine of theta is adjacent over hypotenuse. Well, now we just fill in the unknowns, okay? Now it's a plug and chug. So the cosine of 61 degrees, that's what theta is equal to our adjacent, which is x, over our hypotenuse, which is 10. Okay? And now we just solve for x. Well, first thing that we're going to do is we're going to multiply both sides by 10. That will isolate x for us. So that tells us that x is equal to 10 times the cosine of 61 degrees. Okay, how do we figure out what 10 times the cosine of 61 is? On your calculator. You need a calculator. So I'm going to do it with the computer calculator, but you could just do it with your regular calculators. You need a scientific calculator. Sorry, that's old calculations. Okay. There are trigonometric functions on your cosine scientific calculators. Here I have to actually go and choose it. So the one thing that you want to check is when you calculate something like the cosine of 61, because it's different for each calculator, do you type in cosine first and then 61, which you could see does not work here, okay? It's not going to find, it just puts in 61, okay? Or do you type in the number first, which is true for this calculator, and then you put in cosine, okay? Which is what you would do. This is the cosine of 61. And one thing that you can do if you're checking this right now, which you should have your calculator in front of you, is type in the sine of 30. Okay. So type in 30 and then do sine. If you're getting the correct answer, you should be getting 1/2. So if you're not getting 1/2, then that tells you have to do it the other way. So you can see that if I try doing sine, sorry about that. If I try doing sine of 30, where I do the sine first and then I type in the 30, I get 0. I don't get 1/2, okay? So for this calculator that I'm using, I have to type in the angle first, and then I have to type in the trig function, okay? And you can see that, just so that you know, as the angle gets bigger, so let's just go back to this for a second, okay? As theta gets bigger, so here theta is really small, right? So here, the opposite is really small. We're going to get a sine that's very small. As theta gets bigger, our sine should be getting bigger also because our O is getting large. So let's just write that down. So as theta gets bigger, so does the sine. Okay, because you could see here that our theta is growing. Okay, let me redraw this as a bigger triangle. So here's opposite, here's hypotenuse. Okay, so here our opposite is small and our theta is small. If our theta gets bigger, so now our theta is growing. Our opposite gets bigger, okay, which means that the sine gets bigger. The opposite over the hypotenuse is going to increase because as the numerator increases, okay, the sine is going to increase. The whole fraction will increase. The opposite is true for cosine. As our theta gets bigger, you could see that our adjacent is decreasing, okay? Our adjacent is getting smaller. And when our adjacent gets smaller, what that tells us is that the cosine is getting smaller. Okay, and our opposite is getting bigger, our adjacent is getting smaller. That means that this fraction also gets larger. So as theta gets larger, so does the tangent of theta. Okay, so let's go back and let's calculate this. Let's calculate what x is. So let's go back to our calculator. Okay, we're going to do the cosine of 61. So I type in 61 and then cosine. Okay, and I'm going to multiply by 10. And I get 4.85. Remember, I would round to the nearest hundredth, always make a habit of that. The number after the 4 is an 8, so that tells us it goes up to 5. So our answer here is 4.85. Which makes sense, okay? It's not, first of all, it should definitely be less than 10, okay? This is an angle that's bigger than 45 degrees. So this should be, you're talking about something that's, the adjacent gets smaller, remember, as the angle gets bigger. And the adjacent gets smaller as the angle gets smaller. This is less than 45 degrees, so it's going to be less than half, okay? If it's less than 45 degrees, we're talking about something that's, I don't want to be too specific here. This is a smaller side because it's smaller than 45 degrees. So it makes sense that this is going to be smaller, okay? But it's not going to be so small. If you look at this, this is not going to be a really tiny, tiny, tiny number, okay? And remember, all of it is about ratios. Okay, let's take another example. We're going to do a bunch of these. I'm going to label this A. This will be B. So this time you're given that this is 48 degrees. This is 21. And this is X. Okay, so you want to find X. So you're going to label first. And then you're going to answer each of your questions. So let's label this triangle. We're doing it based upon the angle that we're given, okay? Notice this is a missing side. If you didn't have an angle in order to find the missing side, you would have needed the other two sides so that you could use the Pythagorean theorem. So what this allows you to do is it allows you to identify another side of a triangle without knowing both of the other sides. Here we know one side and one angle, so we could find a second side, okay? So if we label this, X is the side that's opposite. The 21 is the hypotenuse. And this third side is the adjacent. So what do we know? Which side do we know? We know the hypotenuse again. Which side are we looking for? This time we're looking for the opposite. And which trig function uses opposite and the hypotenuse? Sine. So we answered our 3 questions. Okay? Okay. So now it's a pluck and chug. The sine of 48 degrees is equal to the opposite, which is unknown, over the hypotenuse, which is 21. How do we solve? We multiply both sides by 21. So X is equal to 21 times the sine of 48. So we go to our calculator. We're going to type in 48 and then sine. Again, this might be different for some of you. So we get 0.74. Okay, which makes sense as the angle gets larger, so does the sine of theta. So we get 0.74, and then we're going to multiply by 21. And we get 15.6. 15.61. Okay, so we want to round to the nearest hundredth. The next number is a 6, so that 0 goes up to a 1. Okay, let's take another one. Again, we're going to find X. Notice in all of these, we're finding missing sides. This is 22 degrees. This is 14, and we're looking for this. Okay. So what do we do? we label first. So we're going to label our triangle opposite, adjacent, hypotenuse. So the x side is our opposite. This is our adjacent, and this is our hypotenuse. Now we're going to answer our 3 questions. So our first question is, what do we know? Well, we know the opposite. Second question is, what are we trying to find? Sorry, I wrote that wrong. What do we know? We know the hypotenuse. What are we trying to find? We're trying to find the opposite. And which trig function are we talking about? Sine. Notice I always write sine of theta, okay? So this is what we know. That's the first question. The second is what we're finding. And the third is the trig function. And now we just plug in. So the sine of 22 is equal to our opposite, we don't know what that is, over 14. And we've seen this before. What do? We multiply both sides by 14. Cancels. So we get that x is equal to 14 times the sine of 22. And if we plug this in, I always do the sine first. It doesn't matter. It just makes it so that I know I didn't mess up any sort of parentheses. And we get 5.24. So notice the next number is a 4, so we don't increase that number. We leave it as it is. So this is 5.24, and it should be less than 14, right? If you're getting a number that's greater than 14, you did something wrong, because 14 is your hypotenuse. Let's do another one. So let's say that this is 12 degrees. This time, the hypotenuse is unknown. And this is 6. Okay, so once again, you go through the same process. We label. So when we label, this side down at the bottom, okay, side down at the bottom, that's the opposite. The 6 is the adjacent, and the x is the hypotenuse. So we go through our 3 questions. What do we know? Here we know our adjacent. What are we trying to find? Well, our x is our hypotenuse. Which trig function? Cosine. Cosine is adjacent over hypotenuse. Okay, let's plug in. Cosine of 12 degrees is, this time we know the adjacent. So the top is 6 and the bottom is x. Okay, so how do we solve this? Well, we need to get x by itself. Right now it's in a denominator. So it's a 2-step process, which eventually you can skip this step right here. Okay, so we're going to multiply both sides by x. That's going to get it out of the denominator. Whenever you do your algebra, when you have an x in the denominator, get it out of the denominator first, okay? So now we have that x times the cosine of 12 is equal to 6. So now we want to get x by itself. So what do? You divide both sides by the cosine of 12. Okay, so you don't have to go through and multiply both sides by x and then divide by cosine of 12. What you're seeing here is that when x is in the denominator, you can actually just switch the x and the trig function. Okay, that's always going to be the case. If this had been tangent of 72 equals 10 over x, then you would make it 10 over the tangent of 72 equals x. In other words, you can go straight from this trig function set up to this one, which says that x is equal to 6 over the cosine of 12. So you're just switching the trig function with x. That's always going to be the case. Every time that you do this process, that's what's going to happen. So I'm okay with you going straight from this to this. So you're skipping this step. That's fine. Don't skip this one. Set up your trig function so that we know that it's set up correctly and you didn't make a careless mistake in there. Okay, so make sure that you leave this step so that we know that you know that cosine is adjacent over hypotenuse. Okay, and then you can go directly from here to here. How do we plug this into our calculator? You have a few options. Okay, my suggestion would be that you do 6 divided by, and then in parentheses, this was cosine of 12. So then you would type in 12 cosine, close your parentheses, and then you get 6.13. This is a 4, so you keep it as a 3. You don't up it. And again, what are you doing? You're checking for the reasonableness of your answer. So this is 6. The hypotenuse should be larger. If you're not getting a larger number, you did something wrong. Okay? So your answer should be larger. It's not much larger. That's because this angle is so small. Okay? Okay, let's do another one. Now you should be able to pause. We're going to do a couple more. You should be able to do those two on your own. Okay? Let's make this 35 degrees. Let's make this 11 and this x. And then I'll put in the other one as well so that you can do both at the same time. Let's say that this is 18 degrees and this is 7 and this is x. Okay, so you should be pausing, doing these on your own, seeing what happens. So we label first. We're labeling based on the 35-degree angle, so 11 would be the opposite side, x would be the adjacent side, and then you have your hypotenuse. What do we know? We know the opposite. What are we trying to find out? The hypotenuse. And which trig function? Well, the trig function that deals with opposite and the hypotenuse is sine of theta. So now it's a plug and chug. Sine of 35 degrees is equal to 11 over x. Now here I'm going to go through the algebra again just so that you see it one more time. But again, you can go straight to the last step here. You don't have to go through the algebra every time. I'm okay with you skipping it. So we need to get x out of the denominator. So we're going to multiply by x. The x's cancel. So we get that 11 is equal to x times the sine of 35. Notice I switched the sides. That was unintentional, but it makes no difference. Divide both sides by the sine of 35 so that you get x by itself. So we get that x is equal to 11 over the sine of 35 degrees. So again, it's okay if you go from sine of 35 equals 11 over x to x equals 11 over sine of 35. I'm okay with that, okay? And then we go to our calculator and we do 11 divided by, in parentheses, close your parentheses, and you get 19.18. And let's just make sure that this is reasonable. Again, it's a 19.18 because this third number here is the 7, so it's greater than 5, which means this number goes up. Okay, so 19.18. Well, this side is an 11. Our hypotenuse should be greater than 11, and it is greater than 11. It's not much, much greater. This angle is 35 degrees. It's not that large, okay, or that small. So it's not going to be much greater. It won't be much different. 19.18 certainly seems reasonable, okay? That's all you're checking for is, does it make any sense? If you got 10, that wouldn't make any sense because this is 11, your hypotenuse should be larger, okay? Those are the types of things that you're looking for. Let's do the next one. So first thing that we do is we label. So the x is the adjacent. The 7 is the opposite. You don't even need to, sorry, the x is the hypotenuse. Sorry about that. Now you don't even need to put in the a for adjacent because that side is totally irrelevant, but it doesn't hurt, okay? You don't lose anything by writing a. What do we know? We know the opposite. What are we trying to find? We're trying to find the hypotenuse. And which trig function? Sine is opposite over hypotenuse. We'll do one more after this because I didn't mean to do sine both times. So what do we get here? The sine of 18 degrees is equal to 7 over x. So here we don't have to do all of the algebra. We can just say, okay, well then that means that x is equal to 7 over the sine of 18. So see, we skipped all of that algebra. That's okay. So you can go from here to here. And we put it into our calculator. We have 7 divided by, in parentheses, we do 18, and we find the sine. Close our parentheses. And we get 22.65. Let's go back, make sure it's reasonable. We're looking for the hypotenuse, so it should be larger. It is larger than the opposite. And it's much larger, but that makes sense because this angle is not all that big. It's only 18 degrees. Okay? Let's do one last one. Let's say that this is 9. This is x. And this is 41 degrees. Okay, once again, we're going to label. So the 9 is next to the 41. That's the adjacent. The x is across. That's the opposite. And what's left over is the hypotenuse. What do we know? We know the adjacent, right? The adjacent is equal to 9. When we say what do we know, we're saying what length are we given? When we say what are we finding out, we're saying, okay, well, what is x? X is our opposite side. And the trig function is tangent of theta is equal to opposite over adjacent. We plug in. Tangent of 41 degrees is x over 9. We multiply both sides by 9, so we get x is equal to 9 times the tangent of 41 degrees. So now we go to our calculator. We don't have to do division here. So when we don't have to do division, I kind of like doing the trig function first, but I'm going to do it the other way because some of you might like doing it the other way. So it would be 9 times, and then I would do the trig function in parentheses. Okay, so you do 41, and this time you're just going to choose tangent instead. And we get 7.82. Next number is a 3, so this stays where it is. Okay, and when we look at the reasonableness of our answer, we don't know if the opposite would be longer than the adjacent, right? We wouldn't necessarily know, except for the fact that this is 41 degrees. So it's less than 45. When it's less than 45, the opposite will be smaller than the adjacent, okay? And when it's greater than 45, the opposite will be greater than the adjacent. And you could kind of see why that would be, that once you pass the 45 degree mark where they're equal, okay, once you pass that 45 degree mark, the opposite starts to get longer than the adjacent. And before that 45 degree mark, that opposite is smaller than the adjacent. So this is a reasonable answer. It's relatively close. That's because our angle is relatively close to 45 degrees. So just think about it visually, that if we take this and we increase the angle, right, then the opposite side is longer. Whereas if we decrease the angle, the opposite side decreases, the length of that side decreases. So at 45 degrees, the two sides are equal. If we decrease the angle from 45 degrees, the opposite is now smaller than the adjacent. And if we increase the angle, then the opposite is now larger than the adjacent. So this is reasonable answer.